Hello everyone, in this video we are going to talk about all the basic stuffs about NumPy arrays. So let's just start off without any delay. So yeah, let us start. And just for the information, like first, before getting into the explanation of all the machine learning algorithms, I will be first creating the background essential for coding, as well as the mathematical background I will be first creating, and then we will move on to the core machine learning part. So here we will review first some basic stuffs about Python and then move on to NumPy arrays. So the looping statements are of two types in Python: for loop and while loop. You can see the syntax well written. The operations in for loop will repeat b minus a times. I will not take the value of b. It will go till b minus 1. And while loop, it will evaluate an expression which will give either true or false. So unless it is false, the loop will continue to execute. So the indexing are same as the other languages, like the first letter in a list or tuple is a 0 indexed, and the last one is n minus 1 index, where n is the length. And we also have a negative indexing, which starts from backwards -1 and continues till forward -n. And in dictionary, the key itself acts as an index. Like if we want to access a, we will just write a, then within square brackets Bob to yield 59 as output in the given example here. So here the key of the dictionary itself acts as an index. From the last video, I have also shown you an amazing website called Strilstat Hub, where you can just go and practice the basic Python, and then you can also develop and deploy AI models there. So you can do that for basic stuffs about Python. We have completed the basic aspects. Now let us mainly focus on NumPy, Pandas, and scikit-learn. These are most frequently used in machine learning. So we will first learn about NumPy and Pandas, whereas scikit-learn we will also learn, but we will learn it on the go. Like it is a huge library with a lot of modules inside it, so we cannot learn it separately like that. So we will be exploring more libraries and modules as we progress further. So here is one fact for you, that programming in machine learning is about the use of high and storage intensive libraries. Like Python is all about the use of heavy libraries, right? And not about much about programming skill, though you need to have the mathematical concepts of the stuffs and algorithms, how it works. So in this video we will basically focus mainly on NumPy arrays. So what is NumPy? If I tell you to explain in just single line, you would simply say it is an n-dimensional array of integers. That's all. N may be 1, 2, anything. It will maybe 2D, it may be 3D array also. So why NumPy should we use? Because definitely it is easier, much faster, and it is conveniently works with a single data type of integer, and it is a very easy way of performing a huge operations on a large data set, and it is really easy than using lists. So we can import NumPy, like import NumPy as NP generally, so that we don't have to type NumPy again and again. So let us start with the first function. It is an array function. It converts a given list or tuples to NumPy array. First we write the syntax as import NumPy as NP, then we create a list, and then our array, we can convert the list into the array A, and we can print A. The output will be 4 5 7 6 just without the commas. This is the NumPy array. And in Jupyter, if you just write, instead of print a, if you just write a, you know, like in Jupyter the last line is taken as the instruction given by the programmer to the computer to print. So if you just type a, it will be print a double r a y. In words it will print array and then the stuff, and instead of the previous output. So there is also a zero function. It creates an n-dimensional list of array, all of whose elements are 0. We can write np.zeros10. It will create a 1D array that is of 10 zeros. The output is shown. And it can also create 3D arrays of order 2 cross 4 cross 3 as shown here. And to get the dimension of an array, you can just write np.shape, and the inside you would like to mention the name of the uh, stuff whose dimension you want to know. So there is also a shape function in NumPy. So this part is really important, how to slice 2D NumPy arrays. So here I have created a two-dimensional NumPy. The list, first you see the first element of the list, you can take it as one row, and then the next element as next row, and so on. So it is having like 3 rows and 4 columns, this array of so it is a 2D array. So if we convert the list into the x which is an NumPy array, then we can address the slicing x square bracket. First I have written there will be a comma separated, and the first argument in the square bracket will be rows and second argument will be column. The colon simply represents the entire of rows. So when I am writing colon here, I am representing all the rows I am referring, and when I am referring 0, I am referring only the 0th column. So if you see, if I refer all the rows and only the 0th column, we will get only 263, that is the first element from each, right? Because I am first addressing all the rows, and then I am saying from all the rows and only the 0th column you have to pick out elements. So output will be array 263. So see some more slicings, it will be more and more clear. Here on the left side of the comma it is written 1:3. What does this mean? Starting from 1 and 2, it will go till 3 minus 1 2. So I have to refer the rows 1 and row 2. So if you remember, this is the row 0. So I am referring this row and this row, and column from 2 onwards till end I am everything referring. So this is 0th column. I will say this is 0th, 1 2 3. So 0 1 2 3. So 2 and 3 will be taken, and here 2 and 3 will be taken. Why the next two? Because the first argument of rows says that I have to only take first and the second row, and column I have to take second, third, and everything as possible from seconds. And let us see this example too. It says that starting from everything till 2 we will take as rows. So starting from everything till 2, this is 0 1 2, we will take as rows till 2, till earlier than 2, 2 minus 1. So starting from 0 and 1, the first 2 rows I am considering, and column wise I am considering only 1 and 2, 3 minus 1. So you can easily see that is 3 4 and 7 8. So in this way we can perform slicing operations. So in NumPy, if we add to an object, if we add a digit, it gets added to each of the element. This is an important fact which you need to know. And if you subtract and if you multiply, if you divide, it will get added. Operations will get performed with each of the thing. So if this is another important information, that if you address two NumPy arrays like this, and if you just write print m into n, then output will be the product of each term. So if these are two vectors, we can say that m and n will give you the dot product. Not exactly the dot product, they are not added here, but element wise multiplication has happened here. Where you can also use stuffs like print dot sum. There is also options of using m dot mean, which will give you the mean. Here the m dot sum will give you the sum of all elements, that is 11. You can easily see that. Now let us suppose we need to find the Euclidean distance between 2 points. We can do that using NUMPY arrays very conveniently. Like, let us suppose here m and n are 2 points in 3D coordinates, with m being 3, 2, 6 and n being 6, 4, 9. Let's say it's x1, y1, z1, and m has coordinates x2, y2, z2. We know that the distance formula from our high school level will be the under root of x1 minus x2 whole square plus y1 minus y2 whole square plus z1 minus z2 whole square. So what we find here is each of the element is first subtracted, then squared, and then we want to do a sum of all those. So we can assign it like this at variable d, and we can just take the square root of that. So how, let's compute the output, how it happens. 3 minus 6 is minus 3 whole square 9. We can get here 4 and another 9, so we get 22. So it is basically the square root of 22. We can also perform matrix multiplication. There is an option of m dot of n. This basically does the matrix multiplication of m and n. Now there is also condition based printing in NumPy. Suppose we have two data sets of height and weight, and we want to find something called BMI. It is body mass index. We would be knowing it, which is height weight divided by height squared in meters, and weight is in kg. So suppose we are going to display all those having BMI greater than 23. We can write our syntax something like this. So that's all from this video. Meet you in the next video about pandas.